Hi, so today we will be doing combination of capacitors. What is capacitor? It is a device to store electrical energy. But sometimes we need a different value of capacitance what we have in one capacitor. So we combine the two or more capacitors to have some different capacitance. The combination of capacitors can be there in two ways. First way is called series combination of capacitors. When the plates of capacitors are connected side by side, end to end, such that positive plate of one capacitor is connected to negative plate of another capacitor. Then such combination is called series combination of capacitors. So why do we connect the capacitors? Suppose we are having capacitors of capacitance 10 microfarad or so, but we are in need of a capacitor which has we have requirement of some different capacitance, not the 10 microfarad. So we combine the capacitors in such a way that we finally find a combination which has capacitance of desired value. So in series combination, let there be 3 capacitors or 2 capacitors, any value. So let me take 3 capacitors. Of capacitances C1, C2 and C3 are connected across a battery of potential difference V volt. As shown here, you have 3 capacitors of capacitances C1, C2, C3, and these are connected to a battery of potential difference V volt. Now, this battery is supplying charge to these capacitors. Suppose it is supplying Q coulomb charge to positive plate of this capacitor C1 and it is supplying negative charge minus Q on the negative plate of C3, and these are connected end to end. Now what happens? Here you have a system. Let me change the color. Here you have a system of conductor which is connected separately, so it will act as a neutral combination. So this positive charge will be attracting equal and opposite negative charge from this your neutral combination, so it will be getting a minus Q. So if from neutral combination minus Q charge is separated, so obviously there will be equal and opposite charge on another side, and here this minus plus Q charge will be attracting minus Q charge, and it will be leaving a plus Q charge. So first thing what we find, that charge on each capacitor positive plate is same, plus Q in series. No, in series charge on capacitor, each charge on each capacitor is equal to Q coulomb, charge on positive plate, charge on positive plate. Okay, so charge we have obtained. Now potential. Potential, as we know, that it is work done in bringing unit positive charge. So net energy will be equal to work done, and net work energy will be distributed to these capacitors. Suppose V1 work is done in bringing unit charge on C1, V2 work is done in bringing unit positive charge on C2, and in this way you will find that V3 work done means potential. What is potential? Work done per unit charge. So work is, energy is capacity to do work. So net work or net energy must be equal to all the work done. Here let the PD on C1 is equal to V1, C2 is equal to V2, and C3 is equal to V3. Then this is total work done, and it will be, H per energy, H per you have capacity to do work. The two will be same. Therefore, since V must be equal to V1 plus V2 plus V3, and also we know that capacitance C is equal to Q coulomb upon V volt. This is your one equation. This is your equation 2. And let the equivalent, because you are finding equivalent capacitance. Suppose you replace all these things by one capacitor which is having the same capacitance. So let me assume that let the equivalent capacitance is equal to C farad only. Then from equation 2 in equation 1, using 2 and 3 in 1, 3 in 1, we find that in place of V we'll be writing here, in place of V we'll be writing Q upon C. So, okay, let me write it C equivalent. So in place of V, which is equivalent potential difference, so in place of V we will be writing Q upon C equivalent. And charges are same, you can see, so charge will remain Q So in place of V equivalent, we will be writing Q upon C equivalent is equal to Q charge is same, charge in series is same, it is only Q coulomb only, so we will be writing Q upon C1 plus Q upon C2 plus Q upon C3, and it implies that 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this is the equivalent capacitance of the combination of 3 capacitors. When the capacitors are connected in series. Now, parallel combination. Second thing, parallel combination. In parallel combination, the capacitors are connected to common terminals. In this way, you can see, suppose you have 3 capacitors, the same 3 capacitors. Now you are connecting these capacitors C1, C2, C3 on 2 common terminals. Let this point be A and this point be B. So if you connect these points to a battery, so you will have potential of this point VA and potential of point VB, and potential difference of battery is V. Then, since you can see that all these are in parallel, so given, or let me write let PD of point A is equal to VA and PD of point B is equal to VB, then okay, not PD, not PD, let me write it potential. Okay. Because at a point you have potential, and you know potential at a point is equal to KQ upon R, so it is potential of a point, and potential. Now you will find potential difference. Then potential difference PD between A and B is equal to VA minus VB, and this must be equal to potential difference supplied, V supplied by battery. Here you can find that potential difference is same. Here you have V volt, here also V volt, and here also V volt. But since the capacitances are difference of the capacitors C1, C2 and C3, so they will be having different charges. Let it is having Q1 charge, this is having Q2 charge, and this capacitor is having Q3 charge. As their capacities are different, they can hold different magnitude of charges. So let these charges be Q1, Q2 and Q3. Respectively. So let me divide these charges in three parts. Okay. So if you are supplying Q charge, let equivalent charge is equal to Q, then this Q only will be divided into three parts as the charges are conserved, and Q is equal to, it should be equal to Q1 plus Q2 plus Q3 as charges conserved. Charge is conserved. Okay. Now we know that capacitance is equal to Q coulomb upon V volt. So if we have equivalent capacitance C, equivalent capacitance C equivalent. Okay, let me write C equivalent. Then using the value of equation 2 and 3 in 1, on using two and 3 in 1, we find that okay, in place of Q will be writing CV, C equivalent into V, as V is same, all along. You can see all the capacitors which are connected in parallel having same potential difference. So we'll be writing C equivalent V is equal to C1V plus C2V plus C3V. It implies that C equivalent in series, okay, it is in parallel, is equal to C1 plus C2 plus C3. So these are the two ways by which you can combine the given capacitors to have an equivalent capacitance of desired value. Some numericals. Calculate the charge supplied by the battery in the arrangement shown. You have to find the charge supplied. So let me first of all simplify this circuit diagram. So when you shift this part of the circuit along upper side, then you find the two capacitors are in parallel. Let me show you. So here you have C1 is equal to 5 microfarad, and when you bring this lower part along upper side, you get another capacitor in this way. Here this is C2, which is equal to 6 microfarad, and the combination is connected to a 10 volt battery, 10 volt battery. Okay, now let me do it in a simple way. When you notice on these 2 points, the 3 things, this C2 capacitor, C1 capacitor and 10 volt, all are connected in parallel. So PD will be same for all. Therefore, since at common terminal PD is same, therefore if you take the 2 points as A and B, then PD, okay, let me take this one, then PD across AB, A and B is equal to 10 volt only, same. Means VA minus VB is equal to 10 volt for all. Okay. Now you have to find charge in this case and the case of C1. So let me find Q1 is equal to C1 V1, which is equal to C1 is given 5 microfarad into V1 you have 10 volt and this is equal to 50 microfarad, and Q2 is equal to C2V2 and this is equal to C2 given 6 microfarad into V the same 10 volt and this is equal to 60 microcoulomb. Okay, here you have unit of charge and this is coulomb only. Therefore net charge Q net is equal to, since charge is conserved and the net sum of net charge must be equal to equivalent charge. So this is equal to 50 plus 60 microcoulomb and this is 110 microcoulomb. Another way, the same question you can do another way. The 2 capacitors are connected in parallel combination. Therefore, C equivalent is equal to C1 plus C2 is equal to 5 plus 6 microfarad, means 11 microfarad. Now we know that C is equal to Q coulomb upon V volt. Therefore, charge Q is equal to C equivalent into V. Okay, let me simplify this once. Here you have let me simplify the diagram also. Here you have C equivalent and potential the same. V is equal to 10 volt and C equivalent is equal to 11 microfarad. Okay, so let me put the values of the two. 11 into 10 power minus 6 into you have 10 and this is your farad into volt, and this you can write as coulomb only because charge has unit coulomb also. So this is your 110 into 10 to the power minus 6. You may also write microcoulomb. So charge is equal to this much microcoulomb, and further if you want to find the charges separately, then you go further, but you are to find net charge. So this is sufficient. So next question 2. Three capacitors C1, C2 and C3 are connected to a 6-volt battery as shown in diagram. You can see. Find the charges on the capacitor. You have to find charges. So what will be working step? Firstly, you will find equivalent capacitance between the two arms. Okay, so let me start. Suppose this is point A and B. So let me start going. The equivalent capacitance between the points A and B, C equivalent. Okay, let me write it only C. C is equal to, since the combination is of parallel kind, the two capacitors are connected in parallel. So therefore in parallel combination, C is equal to C2 plus C3, and this is equal to 5 plus 5 microfarad is equal to 10 microfarad. Now let me simplify the diagram itself. You have C1 is equal to 10 microfarad, and if you replace the combination by C, this also comes equal to 10 microfarad, and the supplied potential is 6 volt. Here you can go in a simple way. The two capacitances of the two capacitors are same, so they will equally they will have same charges because these are in series. So all the capacitors will have same charges. So let me find the equivalent of these two capacitors. Suppose that is C equivalent. So let me simplify further the circuit diagram. Here C equivalent can be obtained. C equivalent, here you have, okay, let me find C equivalent here. Here you have series combination. Therefore 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2, and this is equal to, when you will put values, 1 upon 10 microfarad plus 1 upon 10 microfarad, and this is equal to 2 upon 10 microfarad, and therefore C equivalent is equal to, just I am inverting, C equivalent is equal to 10 microfarad upon 2. So this becomes 5 microfarad. So you have 5 microfarad. Now you know that C is equal to Q coulomb upon V volt. Therefore, from here you can find Q, which is equal to CV, and this is equal to 5 into 10 power minus 6 into 6, and coulomb, this is equal to 30. You may write micro also, 30 microcoulomb. Now the 30 microcoulomb, it will not be divided. If you give 30 microcoulomb here plus Q charge, on negative plate you will have minus 30 microcoulomb, and this neutral part will divide its charge in two parts because of force of attraction. This positive charge will attract all the negative charges, and this in this neutral conductor the remaining charge will be left on the other side, that is plus 30 microcoulomb. So you see that this 30 microcoulomb is not divided. Actually the same amount of charge is there on C1 and same amount of charge is there on C. Therefore charge on C1 is equal to 30 microcoulomb and charge on C also is 30 microcoulomb. Here you have C, and it has been given 30 microcoulomb, but when C is further taken in its part, means C2 and C3, and here you are giving Q coulomb charge, that is 30 microcoulomb, then you know that charge is conserved, charge will be equally distributed in the two. Now why equally? Because both have same capacitance. It has capacitance 5 microfarad, it also has 5 microfarad. So since they have equal capacity, so these will equally distribute this charge among the two. If they have different capacitances, then charge distribution will be different in the two arms, and that we could find using the value of potential difference, because then product of V and C2 will give Q2 and product of C3 and V will give Q3. Okay, but since Q2 will be equal to VC2, Q3 will be equal to VC3. Here since the capacitances are same, here C2 is equal to C3 is equal to, is equal to C lit. Therefore Q2 is equal to VC, Q3 is equal to VC, same. Therefore Q2 plus Q3 is equal to Q implies that Q is equal to 2Q2. It implies that Q2 is equal to Q by 2, and this is also equal to Q3, Q by 2. So this is equal to 30 microcoulomb upon 2, means 15 microcoulomb. This is your answer.